Thanks everybody for coming out to last talk in track 3. Appreciate you guys sticking around and excited to be get the opportunity to speak at this DerbyCon. I got to speak at the first one, and it's been a whole lot of fun conferences in between, so definitely going to miss it, but this was something that I really wanted to do, and I'm glad I've had the opportunity to do it. So I'm Ryan Linn. I am a security strategist for a financial institution, and I help set some strategy things for their red team, and also do a lot of operation on red team. And so one of the things that we've been looking at is how to do more effective payloads for different kinds of things. So really what I'm going to talk about is an introduction for people who may not be familiar with CACTUSTORCH, what sort of problems it's solving, and basically how it works to see where we started. And then going to look at some of the new stuff that I've been building to really help with evasion, and also to add some additional features and lots of different types of ways to get new shells. So the problem that we had was Office is still a pretty juicy attack vector at a lot of places. I was talking with some peers at other places, and Office macros are tough to get rid of for a lot of people. And so it's still a really good phishing vector, but blue teams now, a lot of the time, can very quickly spot them. And so as a result, wanting to figure out some ways to increase evasion. Things like FireEye and especially Windows Defender have gotten pretty good at detecting these sort of things, and so wanted to up my game there. So can we make it more difficult for the automated tools? There are some things out there that were already out there to help. Things like Evil Clippy and some of the tools that, if you guys saw Walmart Labs presentation last year, they covered a lot of cool stuff. If you're interested in sort of Office evasion things, especially if you're on the blue team, I highly recommend you check out their talk. But those things didn't work so well for me. They still got caught. So I wanted to kind of see how I can improve those. So things that were already out there. Cobalt Strike, which I use a lot for doing threat emulation. It's got a lot of the things that I need in it. And it has Word and Excel macros. But it doesn't really do much for obfuscation. It's really easily caught. I started looking at some other stuff. Metasploit has Office macros, also pretty easily caught. Empire. So props to those guys. They have a payload that works on Mac Office. So that didn't really seem to get a lot of detection from the Mac stuff that I was playing with. So if you guys are looking at delivering malicious code to Macs, that's worth checking out. CACTUSTORCH was one of the ones that I've had some success with in the past. The way that CACTUSTORCH works is it instantiates a COM object inside Office and then can run methods with that. And there's a whole bunch more tactics at ired.team. If you guys want to see some of the other things from history, that's a good place to sort of start checking out. So most of these techniques get caught or are just straight off blocked. Microsoft also did some things earlier this year to make this a little bit harder. You guys may have heard about things like including external style sheets from remote places, stuff like that. Those Office patches went ahead and took some of those away. Defender, like I said, is getting much better at these. Symantec and McAfee haven't as much in my experience from the playing that I've been doing. But IR, when they start looking through the actual macro code, can spot these as malicious pretty quickly. We're going to be looking a lot at OLE-VBA to kind of do some of the triage for this as we look to see how well some things are working. And OLE-VBA is a tool that will allow you to take the macro code out and display it. And also does some basic analytics on it to show you things that might trip as suspicious or that sort of thing. There's also macro stomping. So macro exists in Office documents in two forms. One is sort of pseudo-compiled P code, and the other is the actual text macro. If you create a macro and a version of Office and the exact same version of Office opens it, then it can just use that precompiled code in order to execute it, which means you can just yank all that like text from the macro out. But if it's not the same version, that doesn't work. So in big enough organizations, you're going to have version differences. And so how do you tell like the specific person that you're going after what they're dealing with? And also people with even basic EDR are looking for things like PowerShell spawning from strange places and stuff like that. So wanting to look at how we could maybe get around some of those things. So we have some tools, so we're gonna do stuff with that. Before I get started, just to figure out how deep I want to go in, how many people here have created a malicious macro before? Okay, good. So there's a number of people that have. I'll try to go quickly through this, and then if people have questions specifically about it, we'll cover some more of that at the end. So even with some basic obfuscation, most of the macros that I've seen have been huge. So just a basic cursory IR look is like, okay, that's a whole lot of data. That's really strange. So the things that I found worked the best were CACTUSTORCH, but the default macro is detected by pretty much everything. So that was kind of my starting point, and I wanted to see what I could do to improve that. So first I wanted to go ahead and say thanks to some people who kind of have paved the way for a lot of this. Drew Bonstrom sort of showed me how to combine some of the beginning pieces of this, and that was pretty cool. So the CACTUSTORCH developers, MDSec, and a lot of the people on the screen contributed like lots of things to this that are really great projects to look at, and they can be incorporated in a lot of other things. So if you guys have a chance, definitely check out these resources, because these are resources that I was reading to figure out what I wanted to do. And hopefully, if you guys decide that this is neat and you want to pick up and do more things with it, then these are things that will become really handy later. So first, I'm going to just kind of show what CACTUSTORCH does on its own. So basically, you use the MDSec active breach CACTUSTORCH repo. You clone it out, and then in Cobalt Strike, it has a module that you can load that will allow you to just automatically create the macros. So we'll go ahead and load that up. And when you do, when you come under the attacks, one of the things in there is host CACTUSTORCH payload. So with the host CACTUSTORCH payload, you've got a couple of options. You can use a staged or stageless payload, binary that you'll spawn, and you can pick a language. So you can actually do more than just Visual Basic with these. You can actually do JavaScript and a lot of other stuff. And when you launch, it copies it to the clipboard and you can paste it. So this can also be used in HTA files and all sorts of other things with these languages. Since I'm focusing primarily on Office documents, mine's going to be a little bit different. So from here, we basically create our macro. So we go under View, Macros, and we create a new macro name. One thing to be careful of is this pull-down box has a couple of different options. The one down at the bottom is just your document. You'll have a bad time if you accidentally put your macro in all templates. Not from experience or anything, but when every document you create gets flagged as malware, that's like, so anyway, basically from here, you can see that there's all of this code that is in here. And then down at the bottom, there's the actual pieces that execute this. But anybody that's looking at this sees serialized object, all of this hex code, a whole bunch of base64 code, and like they're going to go, well, that's kind of weird. So here what we've got is we've got a serialized object. We're deserializing it and then invoking the COM object. And down here we see this o.flame. That is the thing that actually spawns the code. We've also got 3 different open functions. Excel can use 2 different ones, and Word can use 1, so it just puts them all in to cover all of your bases. So what we're going to do is we're going to save this as a doc97 document. The reason is docx and docxms are XML files, and things can look into them a little bit more easily. Straight up doc files, they can't, so you can still pull the macros out, but they have a little bit better evasion. So what we're going to do now is let's take a look at what OLE VBA produces for this. So we've saved this document as a doc97 format. My superior typing skills that I even sped up and is still horrible. So when we look at this demo document, what we're going to see is it thinks for a minute, and then we're just going to see pages and pages and pages of stuff that's funny. So we see here all of these base64 strings. It flagged it as drydex, malware. We see all of this stuff that is obviously like information from Windows, executables, all the DLLs it's importing. And so it'd be hard as a malware analyst to look at this and not go, that's malware. And so this is sort of where we started with the initial version. And so, what does happen though is in this case, antivirus is off. We see all of these. And one of the other things, like I said, with the 3 auto runs, all 3 get flagged. When we run the auto run as if we opened it, we do get a shell. So we didn't have a shell before. We ran it, and now we have a shell. Yay, shells. But Defender would catch this. The bad part is the Defender catches it afterwards, so you still get an alert, but it actually does still fire, which is kind of interesting. So that was surprising because I saw the antivirus pop-ups, but it did actually work. So from here, I wanted to figure out what can I do to make this more interesting. And so there are a couple different interesting places to hide your code. Metadata, but metadata can be seen through the GUI, and it also has some limited space there. The image alt tags, I thought that was kind of interesting, but each image alt tag can only have 255 characters. It's hard, like, unless you're mousing over the images, and if you hide all the images, then nobody's probably going to see it. So that's a possibility. The images stay numbered, so you can just iterate through a list and put it back together. But I'm lazy, so there's a better way. Document text was another option because you can hide the document text. But if you convert it to text, it's all still there. And I love my blue team partners, but I would like to make it a little bit more difficult for them. So document variables are interesting. When most people think document variables, they think document metadata. And document variables are a little bit different. Document variables are designed specifically for macros to use for temporary storage in Word documents. They only exist in Word as far as the product family goes, but they can only really be accessed either through the XML or through programmatically. And so saving to non-Word formats completely strips these document variables, and there's not another easy way to get them out. So just the XML, and I'll look at some of the XML with you guys at the end to kind of look at what that looks like, is really the only way to kind of figure this out. So my super creative self decided I'd try to create something new, and my genius naming scheme was Better Torch because it was better. Obviously, that's not where I spent most of my energy on this, but I wanted to make the Cobalt Strike payload work a little bit easier. There were some other things that I wanted to do as well. So I wanted to have some additional injection methods for the COM object. By switching it up a little bit, it makes it harder for things to detect it as new injection methods come out. We can add them in and easily support it with this. It also includes check please, which is another kind of interesting project that you can just pop into your C# projects. And it can check to see if the domain it's running on matches the one you expect, if it's domain joined at all. And just saying is domain joined at all is enough to stop execution in a lot of the sandboxes, because most of them aren't domain joined. And so one of the other things was CACTUSTORCH only supported .NET 3.5. I started running into a lot more places where people had Windows 10 with just .NET version 4. And so this supports .NET 4 and .NET version 3.5. So let's take a little look at what that looks like at this point. So for this guy, basically it's similar. We have a Cobalt Strike payload or a module for this. We'll go ahead and host a Better Torch payload. One of the things you'll notice is there's a lot more options. So we actually have multiple ways to inject our code. And so for this one, we're going to use launch and inject. We're going to inject the code into run DLL32. You can inject into pretty much any process. It'll take both a short name, which it'll look in syswow 64, as well as system32. And it also has Word and Excel support. And we'll go over the Excel support in a minute. But you can easily just click the checkboxes to do the things you want for evasion. So at this point, this has a couple extra steps from the basic CACTUSTORCH payload. So I'm going to load up Word. And from here, create my document and go into my macros. So same thing, remember to put your macros in the right place or you'll have a bad time. Or you'll spawn a lot of shells that you didn't intend to. And so from here, we just paste over the junk that's there. So you'll notice as we look through here, there's a couple things. One is I'm adding an additional reference here. That additional reference is the Microsoft scripting library. And that's because I wanted to use hashes in this. And it doesn't natively support hashes. And I'm lazy. So by adding that, there is hash support now. So basically, there's two functions here. We still see all of this huge code, But the two functions that exist now are a rename me and a delete me setup. So when we come here and we run this delete me setup, then that sets up the document. And here, we basically delete everything but the auto run that we want and delete the old function name. And so we're going to just go ahead and call this one auto run. And from here, we can go back in and just delete that delete me setup. So it now just has one thing that's surfaced, which is that auto run. And let's take a look at what that looks like in the OLEVBA in just a second. First, we're still going to save it as a Word 97 format. And so this Word 97 format, like I said, makes it a little bit harder to detect. And we're going to call this one Better Word. And so for this guy, let's verify that our antivirus is active. So I'm not submitting this to the cloud because I don't like punching myself in the face, but antivirus is on. I also highly suggest double check the submit to the cloud thing is off before you start developing payloads, because you definitely don't want somebody to beat you to your talk. So when we run OLEVBA on this, what we're going to see is this is a lot shorter. We're down to basically 2 methods, and instead of pages and pages and pages of code, that's all the code that exists. So we went from over 30,000 lines of code down to a couple hundred. And now when we open this, right now no shell, and we can open the document, and then hopefully we'll get a shell. I recorded this to make it faster, so we'll see. So here's where all of the social engineering pieces come in. So the other piece is, at this point, we've got the shell. I don't recommend doing the auto run. One of the things that I have found pretty effective is form submissions. You can create fake forms in Office documents for win a free goat or whatever. And then when people hit submit to submit their information, because who doesn't want a free goat, then you'll pop your shell. And also because typically the automatic analysis frameworks don't request those sort of things, then you also have a little bit better chance of doing evasion through that as well. So next thing, Excel documents. Excel documents created a challenge because they don't have those document variables, but I wanted to do some of the same things. So I came back to kind of that same basic set of things, and sheet text had some additional pieces. We're going to go into that in a second, but I could put most of this stuff in spreadsheets and then combine it later. And while people can still export this to CSV and get all that data, we can make it a little bit more of a pain. But Excel has some interesting things. One is it decided that 2 states weren't enough for a spreadsheet. It can be visible or hidden, but it can also be very hidden. And the very hidden, you can't unhide through the GUI. You can only hide through modifying the document properties, where the hidden you can unhide on your own. So we're going to use the very hidden and make it very hidden. The only downside is it only supports 32K per cell, and it also has some quirks. The quirks are it will try to auto figure out, even if you tell it what format something should be, if it starts with a math character, what it should do. And so we're using base64, which has math characters in it. So if it starts with a slash or a plus sign or an equal sign, it's gonna get weird. So you kind of basically just have to move those around your boundaries to get it. But other than that, it's completely automagic. So let's look at what we have to do for that, and also kind of how that ends up playing out in the document. So for here, we have the same basic thing. We're going to host the CACTUSTORCH payload again. We're going to choose the same basic things, but the only thing that we're going to choose different, one is we're going to check to see if the system's being debugged, and the other is we're going to choose Excel. And so with that being done, we can go into Excel and we can do kind of the same thing. So for Excel, you just go to macros, same basic thing. Instead of going to the document, in this case, you just go to the worksheet and you paste all of that in. So if you look, it lands in the rename me from above or I won't run. and delete me setup. So if we just try to run it, what we see is this error message, and that's because the scripting dictionary didn't exist. And so this is a reminder that if you see that, just go back in and add back in the scripting runtime into the references. And at that point, everything will run. So we go back to our delete me setup and we run that. And we saw on the left-hand side that it created a new spreadsheet. That new spreadsheet has a randomly named thing. And if we go down to the bottom, then it has the very hidden attribute. So if we were to close this and take a look, like there's no thing there for us to unhide. We can right click, there's no unhide options. So basically it is something that we can't get to from the GUI. If we go back into macros, we see the two macros that we had. We can delete the setup, and we can go back into the macros, and when we edit it, we can go ahead and clean this up. We're going to go ahead and make this an auto run for Excel and get rid of the rest of that trash. And the other thing that we're going to do is let's take a look at what's actually in that spreadsheet. So when we change it from, and this is for debugging, it's good to know how to do, from very hidden to visible, we saw it pop up immediately. And so all of your text is here. So if you want to make sure that all of the things populate when you run the setup, this is where you would go to do that. And all you have to do to rehide it is to go back in and change it back to very hidden. So, and as you can see, a lot of the basic pieces are still there. One of the things that is added here is there's an additional function, and that additional function is that check please. For this, I wanted to kind of tell a little story. So the class that I renamed this to, and you should rename your classes when you're doing this so that it can help with some of the evasion, is the mystery machine. And Velma's the smart one that stops things from running that shouldn't. And if you take a look at the different code methods, they also have some other names that are fairly appropriate for how they react. For instance, Scrappy will try to spawn a set of code in every thread. So OLE-VBA, here we see that there's an additional thing. We also see this hex strings. So OLE-VBA has an interesting thing where if it sees like 4 or more characters together in groups of 2 that are in a hex character set, it will try to do that. So, you know, randomized character strings, you'll occasionally hit that. You can just rename those variables if you want to. So here, when we run it, this is with antivirus enabled again. And these were definitions from 2 days ago with Windows Defender, and we have that shell. And so we're going to look at what Velma in this case does, the check please code does for this in a minute. That check please code, like I said, can be added to any other C# application, and it's just an easy plugin that you can add to be able to do some basic evasion to any of your C# modules. So if somebody starts trying to debug your code in a sandbox, it won't go. So some of the other things that I wanted to do was add some encryption. And so some of the basic encryption things, one of the problems it had was it added a lot to the footprint. Things like using CHR and XOR and all of those really added to OLE-VBA. Why am I still focused on OLE-VBA? It's just a tool for forensics people, right? So what I noticed is that the amount of stuff that shows up in OLE-VBA output had a direct correlation to my likelihood of getting caught. Now, I don't know like why that is, if it's just coincidence, but what I found is that I started going through and doing more of this, that the fewer things that I had in there, the more likely I was to succeed. So I can get it down to pretty much one thing in OLE-VBA output, which is the create object. Create object on itself is not actually that bad. A lot of things are done with create object in Office, including things like if you want to parse XML or do a web request or anything like that that Office documents sometimes do, especially in Excel where they may pull in from external sources and things like that. Those are pretty common. So the create object itself isn't enough usually to trip anything. So some of the other things, just changing the SID and building in another platform is frequently enough to get you by a lot of the antiviruses. I started building a lot of my stuff in Mono. This project builds in Mono for everything but .NET 3.5 under Kali. I've had some weird things with .NET 3.5 and Kali. But .NET 4 builds fine, and so that was great. Modifying the COM object, changing the COM object's name, the method names. The method names can't be randomized. For COM objects, once you compile it, they have to stay the same. So you can make them random things, but you have to modify all of your code to match those random things, and you can't do it randomly for each instantiation. Obfuscate some more of the object. So right now, like I said, it's in document variables. I haven't seen anything pulling it out of document variables, so I'm happy with it there for right now. But some of the other things that I thought would be interesting are actually using images and things like that with code attached to the end of it in documents, and then put some of those things back together. Or there were some interesting talks yesterday. One of them was using manifests to load code and things like that. So maybe even dropping a DLL out and then reloading another object with the DLL written out to the disk, so it has a multi-part kind of staged thing. Also, on the back end, some of this is based off of Sharpshooter, which is another MD-Sec product that is really cool. And if you haven't taken a look at Sharpshooter, I recommend doing that. And so Sharpshooter actually has the ability to do staged stuff through a lot of different other ways. And so if you wanted to include some of those other things from Sharpshooter in this, most of the stuff that I do is stageless. And so I didn't pay a lot of attention to the staged things. But if this was something that you wanted to add, it should be easy to copy that code in and do some additional pieces. One of the interesting things that I've seen from my forensics days is actually using cloud pieces to load some of those objects from the cloud and pull them directly in from the cloud. So let's take a look at what that evasion really looks like. So for this, basically what we do is we just select the thing that we want, and we can select all of the things that we want to do. So we're going to do check to see if the machine is domain joined. And so we're going to do Word again, and we're going to go through the same basic thing. But when we get into the Word document, we're going to take a look at the Velma function again. And I'm going to go through a little bit more about what some of this code actually does as far as like how it's actually running. So we still need our scripting runtime. And this is something that I'm probably going to get rid of at some point because it's a pain in the butt to click it every time. But for right now, it's the thing. So when we do the delete me setup and we go back into our main function, basically we'll get this renamed. And so when we start looking at exactly what this guy does, we see this additional function called Velma that's down at the bottom. And that Velma function, basically, when it runs, if it fails, it exits. One of the other things that I want to do is to actually give it the ability to return a variable. This is hopefully coming up in the next couple weeks, so that you can actually get a return code from it and run two different types of macros depending on that state. And also plan on adding some version detection for the version of Windows you're running. So if it's something that's other than you expected. So in this case, when we ran it, it just straight up exited. When it straight up exits, obviously it crashed or something, and most people won't think anything strange about it. If Word crashes, then people usually don't worry their heads about it. They're like, well, that thing's broken. So I haven't had a lot of people complain about that so far. But it also stops the debugging in its tracks for what anything would happen in a sandbox. And so from there, like I said, you can actually stack these. So if you want to have multiple of them, you can include multiple of them. And one of the other things that I've been thinking about adding that has been talked about by some other people is actually if you know the domain SID, that's even better than actually knowing the domain. Because if you can programmatically get the domain SID and use that for your key, that is much less likely to be emulated by any of the sandbox technologies. Because most of those will have their own separate domain, and even if it has the same name, it won't have the same SID. So let's take a little bit look at how to build this yourself. One of the things I wanted to do was make it as easy to do to modify and build in your own environment so that you can change some of these things and help with the evasion yourself. So inside Kali, I basically just cloned the project, And from here, we have a couple things. The first one is this assembly to base 64. So for this guy, assembly to base 64 has taken part of the .NET to JavaScript code and reworked it a little bit. One of the things I wanted to be able to do is .NET to JavaScript does a lot of stuff. I just wanted to take a assembly DLL and just pop it out in either hex or base 64. So this guy, what it does is you pass it a DLL assembly or an executable. It will serialize it into hex or base 64 for incorporation or whatever else you want. So if you do the same kinds of things that that original CACTUSTORCH did in other stuff, this makes it very quick and easy for you to be able to take whatever new DLL you want to do with whatever additional functionality incorporated in there. And so from here, wrong button. So from here, all that you have to do is use mono CSC and run it against the assembly to base 64, and you end up with the exe. And so we can call that using mono against our actual payload. So in the payload right now, like I said, this guy's mystery machine. And if we look into properties assembly.info or assembly info, one of the things is, like I said, some of this was taken from .NET to JavaScript and other stuff. This has a GUID associated with it. The GUID here is kind of interesting. You have a couple of options. One of them is to create your own GUID. And each time you recompile it, change that GUID so that if people are doing any kind of analytics just on the GUID in order to block it, then it won't be obvious. But the other thing you can do is you can actually steal the GUID of things that have been abandoned. There have been some interesting comm talks this year that I really appreciated, and a couple of them have talked about comm hijacks. So if you have a chance to look at some of the comm hijack things, a lot of those same GUID techniques will work with this. What's interesting about this is this doesn't actually interact with the comm server particularly because it's instantiating out of memory. It doesn't really care where that DLL is, so you can do some other things here that are interesting. So when we modify it and modify the GUID, we can also modify all of the build information. Right now, all of the build information is stripped out so that having the same build information like the author and all of that won't trip anything. But you can add that back in, and that will make it a little bit more realistic as well. And so once we do that, there is a buildit.sh, and the buildit.sh will go ahead and build the assembly. And it goes ahead, and after it builds it, it copies it into the directory that you're in. And so from here, we see this mystery machine assembly 4.dll. And so we're going to just copy it up a level because I'm lazy. And we're going to use mono with that assembly to base 64 thing. And we're going to specify B for base 64 output and the DLL that we want to do. And we'll just redirect that into a file. And so when we look at that file, all it is like just straight up base 64. And so the reason I did it just straight base 64 and nothing else is I want to just be able to include this file somewhere else. So I do a lot of my development in Vim. I'm sorry. That also means that formatting is sometimes a little bit weird. So if you're reading my code, I double apologize. So for here, we go to the .NET Type 4 payload. And this was all in hex in CACTUSTORCH, but I switched it all over to base 64. So we delete the hex data, and we can just read in that base 64 file, clean it up a little bit, get rid of our spaces, and save that out. And then all that we have to do is go back into CACTUSTORCH or into Cobalt Strike and reload that script. So click on it, reload. If you don't get errors, it's going to be a good day. So if you do get errors, then go back and fix your spaces and your semicolons. So at this point, we just go back through the same basic thing. And so I would update this for each campaign, recompile, change your class type, change your variable name or your method names and all of that for each campaign, and you'll have a lot better success rate. So looking ahead, I'm going to go ahead and say I would love some additional collaboration with this. I've been figuring out some of the stuff on my own, some of the things that I would like to make work. COM is kind of weird, and I've not gotten as much success as I'd like. So if you love building COM objects for fun, I would love to talk to you. I don't expect anybody to come talk to me, but if you do, then that's awesome. So I'm also looking at adding some additional methods and also doing some additional encryption helpers and finding some additional places to hide. So I promised I would talk a little bit about the forensics here. So for the forensics, obviously the docx is nice for forensicators because you can just rename it from a docx to a zip and extract it. If you convert the Word 97 doc to a modern Word doc, docx file, then it does convert all of the document variables into the XML format. So you don't lose anything through that conversion. So once you extract it, there's the settings.xml file. And inside the settings.xml file, you've got most of the stuff that is good. If you look, you'll actually see the docvar and all of those pieces. So if you use an XML parser, you can just pull out all the docvars and do name value, and then just substitute that back in for the macro. And so for the macro itself, I'll pull that up in just a second. For the macro itself, it's easy to see where those docvars are being set, and so you can just go back and put those together back in that order off of the XML. So let me do that really quick. So let me generate a new one. So when this guy actually puts everything back together, oh, I guess not. Thank you. That's more better. Cool, thank you. So when this actually goes to put things back together, this is the function that puts all of that code back together. And so if you just take each one of these and substitute it in for the docvars, you'll end up back with the actual piece. So all of the rest of these are pulling information back out from docvars and from dictionaries and assigning them to things. One of the other things that is in here that Subt was talking about yesterday is manifests. As you add new things, other DLLs that get included, you may have to create a manifest file for it. So one of the things to support .NET 4 in Office is it needed a helper. And so with that helper, the ACTA-CX, I believe it was, you specify a manifest text file, which is just a text file that has where all the DLLs are and what they should load. By doing that, it tells it where to find the .NET 4 components. If you add anything else in that requires additional DLLs, you would just modify that. All of that is in the Cobalt Strike config file, but also is in that setup piece. And then from there, this basically creates deserializers and puts that all back together. So all of this is just basically renamed CACTUSTORCH, and all of your different functions are here. All of the pieces for Velma to do would need to be here after this dynamic invoke. One of the other things you can do if you start getting detected is you can actually pull this chunk out and put it into a different function, and then it's not in the same order, and you can get away with some more with that. So to look back at the manifest stuff, inside the setup function, basically each time it sets a variable, you see this active document.variables equals all this text up here. You can put 32K in each document variable. And so you just have to split your payload into 32K chunks. And so doing that will get you to where you want to be. So other pieces as we come down through here. Oh, the other thing is right now these are 5 characters. And the reason these are 5 characters is if they are 3 or 6, then it will get flagged as base64. If they don't have characters that aren't non-hex characters, then they will get flagged as hex. And so this seemed to be the sweet spot where they wouldn't get flagged as either. So for the manifest, this piece right here is building the manifest. And so basically you have to specify the libraries you want to use and the versions and the public token. How do you figure these out? If you put it into Visual Studio, you can actually look at all of these things. And when you go ahead and configure them and save out the project, it'll put all of this stuff in a file for you. And you can just copy all of this from that and put it in. And so as you add more stuff, you have to do a little bit of editing here. But all of this is a single text string in the CNA file. Also, the dictionary I talked about, if you add anything else, all of these are just key values. So adding another comma and then a key pipe variable. Remember I mentioned the thing that would allow you to load other DLLs. It's this Microsoft Windows ACT CTX module, and that's what allows you to specify a manifest file. So also if you want to do anything weird in .NET 3.5, that's another place where you may have to do it. So, and here for your workbooks, we looked at that earlier. Those are those guys. And again, I don't recommend using an auto open. I recommend using a trigger inside of a document, somebody clicking on something or something along those lines. So, that was most of the stuff that I wanted to show you guys. I wanted to leave some time for some questions and additional discussion. I always enjoy the discussions because a lot of people have run into different things and stuff I might not have considered. So feel free to reach out to me. Also, my code is on GitHub under Cicero for BetterTorch. So feel free to check out the repo there. Everything right now is under the DerbyCon branch. As I finish a couple more bug fixes, I'll merge it to the main. So if you don't see what you're looking for, switch to the DerbyCon branch, and everything is already there today. So thank you guys for coming out. You guys have any questions or stuff you want to talk about? All right, cool. Thank you guys very much for coming. I appreciate it.